We are going to discuss about the something which is related to the secure code analysis tools and tips. And this is the something what you was being using the different tools for the different purposes during your assessments. Uh, so here he will highlight that what are the different tools and which are the more and better comparative tools and why this is scanning we need it and how manually scanning is also means important and it's required. So what is preferable? We may go for the means manual scanning, or we have to go for the scanning which is actually with the help of the tools and so on and so on like that. You can see that the credit goes to the Daryl Parks. This is the one of the professional in the secure software engineering, and they prepare this on based on the industrial means data. So with the courtesy to them, we put I mentioned their names and the details as well. So we see that how and what they are means having the approach and discussion about this. So their major aim is that how to make your code rock, means like how we can make sure that the code what we are writing for any of the program, it is free of the errors and free of the so many issues and the problems. So they adopted some of the different approaches, and then they explain in a detail that in case if suppose some of the organization or the developer they are missing that particular part, then it will be mentioning that the cost of the real cost of the software is going multiple times than the development as well. And also it concludes that in case if suppose we somehow ignore these things, the code analysis part, secure code analysis part exactly, then what happened? Then in some of the cases, even it is not possible for us to means cop up later. Even if suppose we cop up, then the cost will be increased. Even it can be out of our budget, and in some of the rare cases, even if we want to implement, but we cannot get the exact results that what we are aiming to get, and that maybe means bringing the loss for us, and that then it may be creating the trouble and problem for us. So this is how, in other words, we can say that our goal is to about discuss the secure code analysis, its importance, and where it fit and how it fit. And either we go the manually or we need to use the tools. And if we use the tools, then what are the few of the selected tools and what are their main objectives and aims, what parts of the software they're focusing, and so on and so on. So when we start to with the overview, they mentioned, because these slides are presentations from them. So they mentioned that the code analysis is actually means not runtime monitoring. So you may not think that this is the only, one-time monitoring, but we have to be careful. We have to be noticing this, that how and at what state we are supposed to run that, and how we supposed to check, and how we make sure that our whole component, our whole software is working, performing very well. And the other point, he is suggesting us that this presentation is not about the performance analysis tool. So you may not think, you may not get it in a way that, like, suppose at the second part of the slides where we will discuss about the different tools, and like you already used the tools in your assessment number 1 and assessment number 2. So you may not think like in a way that these all are the things which are actually something which are we are trying to analyze, providing the report of the analysis for the tools, what different tools what we will discuss. But we are discussing these tools and these methods and everything with respect to the making or securing our code. Or in other words, we can say that our primary focus is on the code analysis. So now, what about these things about the code what we will be using? So those code we will discuss about the profiling, and those code we will be discussing about the static and dynamic memory monitoring and few of the debugging tools, that how these tools can help us to secure our make secure our code, helping us, and how we can claim that now our code is rocking. That's what we claim that means to make the code more appropriate. So here you can see that the means first of all, he suggested the main source of the information of the studies. He considered that is the code to complete from the Microsoft, that's the second edition, because this code analysis and this part is really important from the day when we started writing the programs. It is not the issue or a problem or concern for nowadays, but it is the issue and a problem concern from the day when we started writing the programs, because the security issue is there, optimization issue is there, and efficiency issues are there. Everything is there. Everything is related with the code. So he said that the main source of the information, what he noticed, that is the code complete from the Microsoft to second edition. So we can even consider anything else, but this is just only what he referred for this presentation. Now, where he's saying that the comparison of the defect detection approaches. So first of all, we have to understand that what are the different approaches and what are the different defects. You remember in the first one, in your first assessment, you was doing what you was focusing on to find out the vulnerabilities. And in the second presentation, what you was doing, you was trying to find out the bugs. So this was means different from the previous one. In the second one, you was trying to find out the vulnerabilities as well as to the bugs. But in our software, there are so many different things are there. So many different defects are there. So we are trying to group them here, and in this table he is trying to group them here and trying to elaborate that which defect is having impact on the software. Like each part of each group of the defects, they have the impact on the software. So from this you can understand that we have these several type of the defects in our software. So you can see from here the informal design review, formal design inspections, informal code review, formal code inspections, modeling or prototyping, personal desk checking of the code, and unit testing, and new functioning, integration, regression, system, and so on. So you see that there are so many aspects while we are checking for the security. We are not supposed only to check for the vulnerabilities. We are not supposed to only check for the whatever the issues in the software or the bugs in the software. But you can see that these all things are highly impacting to the success ratio of the software. So from these things, he's just trying to focus for the three elements or three vectors to focus for our today's lecture. Those three focuses are the formal design inspection, that how the design can be depending or can increasing or can damaging the security. So go back to your lab where we discussed for the one of the motors company where the design was stolen, and then you remember that what happened to that particular case study. So here he focused for that, and he's saying that in case if suppose this is the weak area and we didn't check for the security for this particular area, then the lowest rate of its effect will be 45%, and a moderate rate will be 55%, and the highest rate of effect will be 65%. So this is something which is very, very much important. So you remember when we talk about the security, we always talk about the security. The security is an umbrella, and it has so many different vectors, and we are supposed to take care about all of the vectors. Otherwise, it will be hard for us to manage the security. So in this way, in secure software systems as well, we have multiple ways to detect the defects. So these all are what I'm mentioning here in the table. These all are the same that what we are referring. And then in this lecture, he just pinpoint for the three of them. One of them is the formal design inspection, and number two is the formal code inspection, and number three is the unit testing. So the code inspection, if we are going module to module and function to function, while the unit test is, it means that we are going to test the complete unit. So the formal design inspection is actually that what we just discussed now a couple of minutes before. So these are the means the three aspects what he is trying to discuss just as a sample, so we can understand. If we understand the importance of this one, so it means we can means got the understanding about the other vectors or other parameters as well. But they all are very important. These three can give us the right understanding about them. So going ahead, now he's saying that in case if suppose, as we discussed in the previous table, that there are so many things, there are so many defects in our software, but now what is the cost for finding the means this type of bugs? What is the cost for finding these type of the defects? The cost actually varies. How, what we mean by the varies, because if we find out, we are trying to find out at what stage. Before design, cost will be different. During design, cost will be different. Before testing, cost will be different. After implementation, cost will be totally different. So this is what he means, that the cost of finding the defects is totally means varying with the stages and with the levels. So now he is suggesting the code readings and detecting about the 80% more faults per than the testing. So what do you mean? That if suppose we feel that we are doing the testing and we are using some of the tools, and now we are means got satisfied that okay, this thing is done. So this is not correct. Even the means defects are there. So it means the only using the tools is not enough, and only using the manual mechanism is also not enough, because it is also the time taking things as well. So the whatever he is means claiming, or whatever he is suggesting with the reference to the means some of the reference with the support of the sum of the reference. He's not saying from his own, or we are not saying from our own understanding only. So another organizations, what he said that they found, that organization is also the references given there, that the cost is 6 times as much to detect the design defects. So if we means didn't means follow the policy before the design at the time, means in a sequence, then what happened in case if suppose it comes later and then we are just trying to find out what are the defects in the design, then the cost will be 6 times higher. So you just imagine that the delay, we as much as delay we are doing, as much as the cost is increasing in all of the cases. Then the later study says that the IBM found that only 3.5 staff hours were needed to find each error. So it means for finding as a manually, staff, it means for manually. If a staff is trying to find out the errors, so they require 3.5 hours to inspect the code gradually and find out that what is the means bug. So here the bug, what we mean, those bugs are those issues or those defects which can create the problem for the security. Otherwise, the program is running. Otherwise, there is no means syntax error or no logical error. We're not talking about syntax error here. So again, he is putting the means example for this one and saying that 3.5 staff hours were needed to find each error when using the code inspection, where 15 to 25 hours were needed to find each error through the testing. So now what it means by testing? Testing is something different. It is not the means the tools what you are using. The tool analyzer is something different and testing is something different. Testing is actually the part of the SDLC as we discussed earlier. So testing is there, and after that we are going for the implementation. During the testing we can find out the issues and the problems. So what he is saying that if suppose we are just using the testing, so the testing is required 15 to 25 hours to find out the one error. This required a lot of time. The cost is more in that particular case, while the cost is less in case if suppose the staff members, they are trying to find out the journal specific error for that particular part. What it is mean, this point is very important. You need to understand it well. This means that in a testing, like suppose you remember that actually what happened that in case suppose we are releasing the software. So most of the companies, they are releasing their software in beta version. So the beta version is actually the advanced version of the testing, because they are ready to receive the comments during the beta version, and before the final version, whatever the errors and the comments received from the customers, so they can address them and then they can means improve them before the final release. So that is the means advanced version of the testing as well. So what he is saying that the testing on an average, it requires 15 to 25 hours. But if we have the dedicated staff members, to find out the defect and detect inside it, then it will be easy for them to find out from 3 to 5 hours. But again, this is the cost in terms of the timings. Now, what is the next? The next is saying that the combination of the design and the code inspection usually removes 70 to 85, in between 70 to 85% or more of the defects in a product. So it means combination is required. Combination of what? Design and code. So we are just going back to the table. So you just refer here that we are taking these three parameters. The one is the design and the other one is the code. So if we are just only inspecting the code, then again it will be not good. Are we just inspecting the design, then again it is not good. If we are just inspecting the unit testing, then again it is not good. So we have to take care about these all things. Now what he is claiming there are suggesting us, what the studies are saying, that when we go for the design as well as the second parameter, which is the code, then we are able to remove the 70 to in between from 70 to 85% defects. So the designers, they can the coders and designers, they need to learn together, they need to sit together, they need to work with the mutual understanding, with the mutual optimization, and then again we have to go for the testing for both of them. So inspections are required and they can increase the productivity about 20%. So if we continuously do the inspections, security inspections, while the design is in process, while the code are in process, while we may not wait up to the unit is ready and then we are going to deploy, and after that, then it will be the cost will be increasing. So in the same way, you can see that the 10 to 15% of the project budget, and it will typically reduce the overall cost. If we have this mechanism, we start at the right time, then what happened, this even help us to reduce the cost, the overall cost of the software. In case if we are not following, then it will increase the cost of the software. So how come? What it means increasing the cost of the software. So in case if suppose we implement the software and the software having so many issues and the bugs, what happened, that software will be reported back to the company. And again, we need the human source. Again, we need the hours to work on that. And again, we need the investment to finish that job. And then it will be increasing the actual cost of the software. So how and why he is saying, he will give you the 1 or 2 examples so you can see in upcoming slides. Now for the best results, what we can do. For the best results is that we may not go individually. We may not go for the something. We may not go for the one vector and we say we done with the code analysis, so now it is secure. We may not say that we're done with the design, so now it's secure. We may not say that we're done with the unit testing, so now it is secure. We may not say that we have a very thorough testing and the beta version testing as well, now it's just done. No, we cannot. The best practice is that we have to combine all of the approaches. We have to see for everything. We have to make sure that everything is combined mutually, and then we verify that everything is working fine. Then we can say that now our software has the good efficiency, which can be 80% or 85% or more than 85% like that. So what he's saying, the typical organization uses the test heavy defect removal approaches and achieve only 85%. So if you go for any one of the component or any one of the parameter, you will not be able to remove. We will not be able to remove this one. So for this, we are supposed to go for all of the aspects, and we can use the manual approach. We can use the tools as well, and we have to go in all of these steps, like what we discussed in the SDLC and so on and so on. So now here, what we discussed, he is giving us the few of the industry examples. He's saying that saving of 150K, a real world case study is there, that before the code, if the bugs are remaining when we done after the development, if I just make a pointer to this one, this will be more good and easy for you to understand. So you can see from here that this is the pointer. So in this, after the development, how many errors are inside? So this is 463 errors are there. Now, what are the number of the bugs after the QA testing? If suppose we are going for the QA testing, which cost, the QA testing is costing us 200, say for example, dollars. Then what happened if suppose we go for after the customer? So after the customer, this is the beta version, or even after the beta version. So what happened then, even we means address them, we make them ready, we make it done, but 463 means errors are there. Then what happened when we go for the testing, again, is still around the 3 to 1. So this is only a one case study, just to give you an idea. This is not necessarily that this is the right and exact number for any of the software. This maybe varies in software to software. So then what happened, even we are receiving the feedback from the customers, again, is still there are the bugs like 194. So if you just compare from the 463 number to 194, so we can say that is still, even after we getting the feedback from the customers, is still there is the chance, there are the chances that 40% of the bugs are there. So normally you notice that most of the applications, as a user we are using, and user are complaining, oh, this application is not working for this, this application has this issue, and so on and so on. So you can see from here that the fixing of this cost is means for the bugs, what the bugs we are having. Then if we are going to fix them, then it will increase the cost of our software. So that's what he means, that it actually impact, very badly impact on the software cost. And the cost is the everything. If suppose we are going out of the cost, then even the software is not useful for us, other than the security parameters as well. Now what happened if we just go to the next slide? So here he is saying that if suppose we try to do all of the mechanisms properly at the right time, then what happens? Then it means that the bugs will be less when we will be releasing the product. And in that case, the bugs fixing cost will be reduced, and this will have the high impact on the budget, as well as this will have the high impact on the success of the software. So this is a highly important, and we can find out so many case studies and so many things. If you just Google it, you will find out a list of the a very detailed list of the softwares. They were failed because of these reasons. They were having the bugs in their software. They have the loopholes in their design or in their unit testing or wherever. So somehow they cause the security issues, and finally either those software were discontinued, or either the customers, they didn't trust on that particular software. So finally they were not successful. So these are the major reasons for the success of the software and for the failure of the software. So that's what he is focusing on this. Now, what is our purpose? Because we understand now that how important is to make our code rock. How important is that to make our code clean? How important is that we have to make our code safe? So then we will be able to say that we can save the cost, we can make the software successful as well. Otherwise, none of the goal we will be able to achieve. So this is actually means our purpose, that we have to clean our code to improve its quality and higher, and as it can be successful. So how we can do that? He already suggested us that there are so many different parameters. There are so many different factors, and we are supposed to handle all of them, and we are supposed to take care for all of them. So jointly means then we will be able to improve the quality of our software. Now, what happened? Now he is suggesting us the different tools which are there to help us for these issues, what we discussed. Those issues for improving their design, improving their code, improving their unit testing, and for all of them. And you remember you also used already the couple of tools in your assessment number 1 and assessment number 2. So probably you will find the few of the tools familiar and similar while we will discuss, and probably you will find the more number of the tools. But again, these tools are only mentioned, the few of them, just for your idea. Otherwise, we have a number of tools which are available for this purpose. So what are the advantages of the code review tools? They can track the code for us, and then they can provide the suggestions to us, and you already use for your assessment, so you know that how they can produce the reports for us. So we can find out that how many vulnerabilities are there, how many bugs are there, and how many and where and what part the issues are there. So they can add actually comparison between and after the code, and they can give us the hint, and most of the time they can get us to the right point at where is the issue, and in most of the cases they don't, but they can provide us the tip or hint, so we can be cautious and we can take care about that particular unit or particular code segment or function or method to find out that how and what is the issue in that particular part. So list of the available tools. So many, but we just, as I discussed it, we just mentioned here a few of them for this. So what are these? So you can see from this list, these are the Crookable, Code Collaborator, and Review Board, and Code Striker. So many, and you will see in the upcoming slides as well, and few of them we will also discuss, and probably you already discussed, used already for your lab assessment previously. So now, what are the code review issues? If suppose we are done with the code now, this is your job that you are supposed to review. It is highly important. It is truly important because this is something which links with the success of the company, organization, software, and everything. But it is fact as well at the same time that it's a time-consuming job. It's a job to be done with patience. Okay, it's another something which is going to be done in the enjoyment, but it is time-consuming. It's a boring, and sometimes it is embarrassing. And so maybe sometimes the people who are doing, they feel that they are just rubber stamping, they are just trying to find out the errors and do this. But no, this is really, really important, and we are supposed to do means for each of the code of the segment. Otherwise, even the huge and giant companies, they lost their reputation and they gone out from the means market. So if you remember that there are so many cases, like if we consider the one of the case that is about the Nokia. The Nokia was the one of the brilliant company in cellular phone, and there was no other company in its competition. Even there was nothing, the company close to it. But what happened then? Finally, they lost the battle just because of their software, what they are using, and the other companies they means get the complete market share just because of the software. So the design, the hardware, and the other aspects, Nokia was very good, but it lost a battle just because of these issues that the softwares were not good. So this is the something, it's very important. So now the next, what are the other code analysis, which are the automated code reviewer? There are means now the tools we have in this separate classes. The few of them, they are automated. They are means intact with the compiler when the coder is writing the code. So they are providing the analysis and then they are suggesting some things to us. The other thing is that they are the static code. Once we're done with the code, and then we can test them. The others which are means the dynamic, like suppose we write the whole code and then when we compile and then at that time they can give us. So there are the different means pattern and different tools, and there are so many number of the tools. So here the code analysis, like how we are doing, these are the automated code reviewers. So finding of bugs, PMD, check style, and JDepend, the CKJM, CPD, and Java, CSS, and so on and so on. So there are so many, but again, we cannot means enlist them here, but we just try to means list a few of them for your better understanding and just to give you the means idea that how many and how different tools are there. Now, finding the bugs. This is find bugs is the name of the tool. So you just go back. So you can see from here, this is the number one tool. So now he is just trying to discuss about the find bug tool. So this is actually based on the what concept? It is the on the concept of finding the bug. You remember you did your second assessment. So your job was the finding the bug. So this was the maybe the best tool for you, find bugs pattern. And this is what he's doing. This is actually a bug pattern in code, and it will find that the difficult language features, misunderstood API methods, and misunderstood any other issues are there. So it will find out, it will help us to find out the bugs, but uses the static analysis, okay, to inspect your Java code, to inspect your even bytecode, and to go inside and try to find out that what are the anomalies and what are the reasons and what are the issues with this one. So this is the means the code which is highly recommended. So we just choose the code, or he just choose the code which are the most commonly and highly recommended. But again, he said that this is the code which can provide you the efficiency of the 50%. So the 50% you can be means considering that this is good, and it can means help you to find out the things. Now, what the next means categories, which is actually the find bugs, is focusing in the code, because in the code, if suppose the bugs are there, so even the bug itself, that itself have the multiple aspects. So what are those aspects which are being covered by this find bug tool? So it will see for the bad practices, for the any correction which it is required, or any security issues are there, or any code optimization or performance issues are there, or any part of the dead code is there. Sometimes the dead code, it means we are writing and putting comments, and sometimes we write the some code and then we are not utilizing it, but it is there. So it will check for means everything and any experimental or any of the multi-threaded or any of the issue. So these things are actually the part of the find path. But this will only focus on these things. This will not focus on other aspects or other parameters. While we have, there are so many other aspects and other parameters as well. So you can understand from here that the find bug is good. It can means give us the 50% reporting, and this is mainly focused on the finding out the bugs and what are the heads it is counting or considering. So these are the details given here. So then it will generate the reports for you, like what you did in your assessments. So this will be providing us the reports. So this will be the file, that this is the file and this is the detail and how many bugs are there. So you can even count the bug and then you can go to the detail type of report, and then you can see sometime it will means intimate you exactly what the bug and where is the bug, and sometimes it will give you the means caution or tip, so we can means follow that and we can fix it up, that what is the issue, and could be that issue will be creating a problem for us. So this is the one of the means find bug tool, and you can see these are the samples of the report. So you can see from here this is doing like this, and it can create the Excel sheet for you, it can create the journal report for you, and it will pinpoint for any of the software. Now the second one, which is the PMD. So we just go back, so you can see from here that in the list, the second one is the PMD. So now he's just trying to discuss a few of them today. So in PMD, you can find that PMD scans the Java code. This is mainly for the Java code. So we have the different tools. The few of the tools, they only scan for means particular languages. Like for this, it is scanning for the Java tool, because maybe this tool is written and designed for the Java compilers. So in the same way, if we have the different compilers, so we will have the different codes. So this is also a wise means selection, by we are means creating or choosing or adopting the tools. We are supposed to adopt the right tool for us. So what things it is going to be means find for us? It was going to find for us the possible bugs, dead codes, and suboptimal code. Suboptimal code means it's increasing the performance for this one, and overcomplicated and duplicate code, and these all of things. Maybe sometime we are using the duplicate code. So the duplicate code can be means having any issue, security issue. It can be the point of exploitation or vulnerability in the future. And maybe that this is the means decreasing the performance or optimization of the code as well. So this is the PMD, and this is also working for the Java code, and these are the heads which the PMD is actually going to consider. And then inside the PMD, there are the rule sets. There are so many rule sets. So you can see from here, the rules are for the Android, the rules are for the different things as well. So whatever it depended, whatever the type of software you are using, so you can go and set the rules, and then it will be means it will be easy for you to find out the right report. If you will not set this means rule set, then there will be the chances that it will randomly bring the results for you, but those results are not as accurate as what we are wishing. And but again, as you remember that we discussed, that it is suggested that we may not go only dependent on the tools, or we may not go only the manually, but we have to go mutually, and we have to use the multiple ways to means come up to fix the as much as possible these bugs and issues and the errors, so our success rate will be higher. So these are the enlisted means PMD rule sets. So it depended what type of the requirement, in case what type of software we are using, and what is our testing, and what is our means aim or goal. So depending on that, we can select any one of them. Now, what is the next? These are the means PMD rule example. In case if suppose we are going to choose the basic rule, then what it will do, and if suppose we are going to select the other rules, then what it will be happen and how it will be taking the information from us. So these are the rules with the PMD. So we put it in an order that while we are going from previous to the PMD, it means the PMD is actually means more good, comparatively more good, and comparatively more powerful compared to the find bug, the one which we just discussed previously. Here we have more leverage. Here we have more capabilities, so we can fix the things and we can find out the things as well. Now, this is the report sample for the PMD, like what we saw the sample actually for the previous one, find bugs. So here, this is also, because this is the, for any analysis tool, this is the necessary and very important part. Any tool which provides us the detailed and comprehensive report, that tool is normally considered to be the best tool. Because why we are doing this, all of the analysis, we are doing this, all of the analysis just to find out the right issues, right bugs, and right problems inside the software. So this is the reason. This is the reason. That's why we are actually looking. We are actually looking for the detailed report. Now, going ahead, you can see that now we are discussing the third one tool, which is actually known as the check style. So this check style development tools to help the program write the Java code and adhere the coding standards. So what are the pre-found structures and coding standards? So we have to follow this, and sometime while we are writing the course, so what happens is it will just automatically go to set our code in that particular standard. So nowadays, most of the compilers, they have this by default. So when we go for this, so it is automatically taking us and considering in our consideration. So you can see that this is automatically can fix the code. This is called as the check style, with the help of the check style, but this is called as the code design, proper design, because this can help us that, to find out the issues and error as well. So now the check style, how it is working, if suppose we apply the code, so it will bring us the report, which report is containing about all of the information, like the files and how many weaknesses we have, how many warnings we have, how many issues we have, how many problems we have. So we can pinpoint to the problem exactly, and we can fix them. So this is how it is helping us. And also the dead code detectors are there. There are the tools which are only focusing primarily for the dead code detector. So why? Maybe you are thinking that why these things are. Like suppose when we have the good level of the software, advanced level of software, say for example, if we say we have the Windows. So what do you think that how many lines of the code will be there for all of the modules? Say for example, we have Microsoft Office. How many lines of the codes? So the line of the codes will not be in hundreds or thousands. It will be so much. So to finding the dead code or finding these issues within this, it will be very hard manually, and it will be very hard for us. And those type of the software, they are taking years to develop. So in the years, the coder, they are writing the codes on a daily basis, and so many lines and so many times they are writing and deleting and commenting and doing something. So there are so many chances, there are so many issues there inside for the optimization and for the dead code and so many other issues. So that's why these tools and these inspections are necessary. We have to have. So this is the dead code detector, which can detect the dead code from that particular part, and it can pinpoint, and then we can fix it up. Now the other miscellaneous tools, there are so many other tools as well. While we are saying the miscellaneous tools, it means that for some of them, they work on a static, some of them, they work on the dynamic, some of them, they work on for the design, some of them, they are working for the finding out the bugs and finding out the dead tools like that. So this is the a class which is the combined together. So you can see from here that this is the CKJM, then the Java and CCS, depend, and so on. Means that again, we have a very great list. Maybe you will find out the number of the tools in hundreds. So you remember during your assessment, I said, yeah, this is your task, this is your learning. So you just go and find out. You will find so many tools. And I remember the one time you said, sir, can you just give us the number or name of the tool? But I said, I don't. I will, you can try. So that is your task actually. So what it is the task? Because once you go, then you will be able to find out the different tools. You can apply those tools, and then you will be able to see that which tool is actually better and which tool is not better. So this is how now I believe that you will be learning that there are so many tools really, because so many tools what we are discussing here, maybe till now you didn't adopt it or used any one of the tool for this for your assessments. Now, the structure of the tools, they are actually, whenever we run the tool, they are actually going to understand our code and read the code and read the routines, read the functionalities, understand the flow of the program, and then after that, they started working to see that what things are necessary and how. So all of the tools, they are working based on these, some of the algorithms, but they are designed. So there are so many means other architectures and quality in-depth monitoring for Java, and you can find out the further details from this Wikipedia link as well, and you can find out the so many tools. So the tools are not ended here, and still there are so many. We are still in a process to discussing. Then the next tool is the Xradar. This is something is means very good tool. See any tool that this is a very good or excellent tool, because after the Xradar we will discuss the Sonar. So probably you discuss about the Sonar as well. So Sonar is even more comprehensive and more good tool compared to the Xradar. So Xradar is the open extendable code, and this report tools currently supporting all of the Java-based applications. So this is actually that you can find out. This is the one of the we can say one of the best tool. Yeah, we can say like that this tool is, and then this is actually can be working for the code extendable and can generate the reports and mainly focusing to the Java, and it also can go for the batch processing and for the HTML and for other things as well. Now, how Xradar is going to be linked. So this is how we are linking with our software. And then when we are going ahead, so this is the reporting mechanism, and you can see that how this reporting mechanism is actually there, and how this is bringing a comprehensive report for us. So in this report, if you can see that what is the means, I can use the pointer. So the source size, you can see the duplication degree, how much is the duplication, what is the errors, and what is the code, and what are the error responses, and the lack of Java and code of complexity, and so many things. So this is, we call it radar because it is providing us a comprehensive report, but with the different aspects. So that's why it is considered that it is comparatively good. So you can see that it is comparing, controlling, considering the multiple factors are the multiple factors. This is why we call that this is the some of the good tool. So now Sonar. Sonar is we can see, we cannot say it's an excellent, but if you allow me, I can say this is a very good tool. And even if we compare the Sonar tool with the Xradar or the previously whatever we discussed, this is more comprehensive and more good. So, but we cannot say excellent because in each day the new tools and new things are coming. So probably the day we are discussing about some tool, maybe the new version for that one, or maybe another tool is there, which is even working shiner and finer and more significantly from that one. So we cannot say as a word to end that this is the best tool, but we can say that this tool is, whatever the tools we discussed, you will find this is the one of the best tool. So Sonar is actually a very comprehensive in reporting, a very comprehensive in options, and very comprehensive in optimization, and very comprehensive in the performance as well. So its dashboard means also very good, and it can summarize the dynamic analysis tools, and it can provide all of the services. Like suppose you remember the previous tools we discussed about the check style and PMD and find bugs. So find bug was different from PMD, PMD was different from check style, and everyone was having to focus to the some specific purposes. So you remember the check style was focusing on the styling, and the PMD was focusing on some other parameters, while find bug means focusing on some other parameters. But the Sonar is focusing on dynamic issues, as well as it is covering all of the things what are covered by the check style, what are covered by the PMD, what are covered by the find bugs, and also it is covering that what is covering by the other tools. But we just name it these three here because we just discussed these three, so you are aware about that one. So in other words, we can say that Sonar is a very powerful tool which is coming up in addition to the other list of the other tools what they are providing. So it is covering those aspects as well as the other new aspects also. So now you can see from here that this is the Sonar example. for the means the front end for the dashboard, and it is keep updating with the versions. So you can find out here that how much is the coverage, how much is the complexity, and how much is the bill item and links and everything. So this is something good. So you can see further. So this is the means Sonar is also giving us the means warnings, giving us the alerts, and means producing us the reports and pinpointing what are the issues and where these issues are and how much these issues are, what is their complexity, and what is the complexity of the classes, and what is the complexity of the methods, and what are the unit testing success. And so it means it is covering in a more depth. So that's why what we discuss here, that it is means covering also those tools what we discussed previously, and also it is providing the more in addition as well. Now, what happened? The means reading the Sonar tendencies. So it is covering a lot of things, and it is runtime. So when we are fixing the things and we are running these things, means the Sonar, so it will be a runtime updating us with the means red and green arrow, and that means with the different tendencies that what it is mentioned here in the table. But I'm just putting the means red line with the mouse pointer so you can understand it well. Now, what is next? In the application dashboard, you can see that how much it is expecting, how many lines of the code. So you just see here how many lines of the code. So now you understand it why we are saying that it is hectic to do the manually, but we are supposed to do. And how many lines are. So you see these lines are in thousands, okay? And how many classes are in that particular means program, and how much complexity is, how many the duplications are. So 67.7% is the duplication, and this much percent is the means the comments are there, okay, like what we are putting the comments in, how many methods we are using, and what are the rules they are following, how many violences are there, and what is the code average, and what is the test is done 100% for everything, nothing is failure. So just see this covering all of the different aspects. That's why you remember we said that we can say that this is the one of the best one. Now, the further reports from this one, you can see that it is even more comprehensive about application to application, method to method, classes, how many methods, how many unit testing are there, how many applications are there, how many APIs we are using. Means it is going in a very depth, and also you can means evidence that it is providing us each and every detail, that how many lines, how many means even the comments are there, how many duplications are there, how many methods are there. So it is means covering each and everything. That's why we are saying this is something very good. So if you just go to the Sonar means violation drill downs, that in case if suppose you try to find out that if suppose it is suggesting this much number of the violations, so you just go inside and you will find out that how many and where they are. So this is actually not only finding means correctly, but it is focusing correctly and pinpointing to the right positions as well. That's why we call normally that this is the one of the best tool, that what we just said or discussed a few minutes before. You can try this one if it is means licensed one. You can try this one for the means free trial version. So you will be amazed at see that how the Sonar is means powerful for your testing. Now, these are the other means graphs and the details about the code and complexity and the coverage and how many like suppose the issues are there. So everything is going to be covered by this Sonar. Now, this is the Sonar Cloud. Means Sonar has the different versions. So it can go for Sonar Cloud, it can go for the hotspot, it can go for any of the. So as we discussed, that this has a wide range. It is providing us the comprehensive reports, as well as it is covering more, and as well as it is covering the all of the other aspects, that those aspects what we are covering with the other reports as well. So you can see from the Sonar Cloud aspect as well here, and Sonar Hotspot. So these are the further details. So you notice that for the previous means tools when we were discussing, we witnessed their reports. They were not very much comprehensive like what the this report is the comprehensive, and how much it is in a great detail. So going ahead again, if you just drill down it more, so you can find it out that it can take you to the particular part of the code or the segment, and it indicates that where and what are the issues. So this is how means you can see, and you can even install the Sonar plugins in Motion Charts, so it can means create the chart for you. It can give you the right information at that runtime as well. So that's why you remember that we can say that the Sonar is the one of the best. So now I believe that what I'm saying, this is justifiable if we just compare it with the previous tools. But we cannot say that this is the only best tool, because every day new things are coming, and there are so many different tools which are available for the open access, and so many tools which are available under the license, so many tools which are focusing only for the bugs, and focusing for the design, and focusing for the style, and focusing say for example for the static group, and focusing for the runtime group, and focusing for the compilation time of group. So we can say they are in hundreds. So now I hope that you got a clear picture while you was trying to find out a few of the tools during your assessment, and you are thinking that maybe the tools what we mentioned in for hint in your assessment, they are there, and maybe there are the few 7, 8, 10 tools are there. But no, this is a means very independent and separate world where you can find out all of the details. So now you can see here in timeline. So we can see that in timeline that how it is working, what it is version, and how it is focusing, and so on and so on. So now other code analysis tools are also there. The Sonar we discussed, the XRadar we discussed, and Check Style we discussed, and PMD we discussed, and so many things. We just named them. We didn't go through in a means great detail for them. But again, it's so there are so many. Like suppose these are the code analysis tool, which is known as the Intelli or Intel IJ, or whatever IntelliJ, whatever you means pronounce. It's up to you. So it is the one of the very easy to use and come a free version, easy to install, and this is the third generation tool. So there are so many tools. So we cannot say that this is the fixed number, that there are the 7 tools, 10 tools, 100 tools, 20 tools. No, but there are so many different tools are there. So this will help you to understand these things. Now in IntelliJ, you can say that this is the means from the Java group. So you can see from here that how it is IDE can work, and how many issues are there, and how it can means bring things, and it can locate the dead code, it can detect the performance issues, it can means improve the code structure and maintainability, how it can be maintained, and how these things are done. So everything is going to be means controlled with this one. So now if you just go ahead, so IntelliJ, this is most of the time you are using in your compiler, I believe, in your most of compiler while you're writing your programs during your different modules as well. So these all are the tools we discuss, and we discuss in a pattern that how and why these things are important, and we try to that these are the secure code analysis and tools and tip how we can make our code rocking. And again, the credit goes to the Daryl Parks, the one of the expert for the secure software, which is actually means presentation is done by him. So it can give us a clear picture that how much it is important, and how and where we can start. We need to start in a parallel. We need to focus on the tools as well as we need to focus on the manual as well. But the cost is actually varying depending on when and where we are starting. So time of start is a very important. If we start at the initial level, we will have the less means amount of errors. If we start at the middle level, then the cost will increase. If we will start at the end level, then the cost will be again in further increase. If we not to start these things, then the cost will be maybe 5 times to 7 times of our real cost of our software. And even there are the chances that we will not be able to keep that software be successful or working. So these all are the things which are important, and we learn that we have to go for the means collective approach, not only for manual, not only for tool. And we also learn that there are so many factors, there are so many vectors, there are so many aspects of the software. So if we just focus on the code, so we may not be happy that this is now done. No, but we have to means consider all of the things, like considering the design, considering the code, considering the testing, considering the QA, considering the unit testing as well, considering the beta versions as well. Means everything we have to consider. And after that, only we can say that there are the chances that our software will be successful. Because once success, always success. So you can notice there are so many software, they are running since years. So the once success, always success. But once failure could be changed to the always failure. It depend that what type of failure is. It depend that what type of the negligence was means done by the security engineers during the process. It depend that at what time they adopted means code analysis schemes that what we discussed. So this is how, and this is all about the concept what we are supposed to discuss about today. So thank you very much. If you have any question, please let me know. Otherwise, we can go for your attendance. So you are welcome for the question. If suppose you have any question, please let me know. Otherwise, we stop the recording and then we will go for your attendance. Okay, then we are going for your attendance. I just stop this screen so we can share with you the attendance. And before that, we're just going to stop the recording. Thank you very much.